Okay, so in this tutorial we're going to be looking at atomic structure in a little bit more detail now, and this follows on from the last video on the foundations of chemistry and the periodic table. So we're going to be looking at some specific elements and how they're structured and how we draw them and how we represent them. So it's really important now to remember that atoms make up absolutely everything, so everything ranging from carbon and hydrogen and oxygen and all these things we're used to knowing about. They're all made up of atoms. Now, we've got a key down the bottom left that I'm going to keep referring to throughout the video. We've got these red particles here called protons. Now, protons are positive. They have a positive charge on them. We'll come back to what we mean by their charges in a minute, but it is really important we understand these. Neutrons are neutral, they have no charge, and electrons are negative. Now, the first part we're going to be looking at of the atomic structure. So at the moment, we've just got this ring. We're going to fill it out now and have a look at what we mean by some of these things. So first of all, we find protons, these red particles, in the nucleus. So you get these positive charges, and they're only found in the center bit here, the nucleus. In addition to protons, you also find neutrons in the nucleus. And we find these things clumped together, they're grouped together. So I'm going to put in here, you can see we've got one proton at the moment and one neutron in the middle there. Now, in this ring around here, this is called the shell. This is the shell, because it goes around it, so it's the shell. It's also commonly called an orbital as well, so it's good to know these interchangeable terms. So in the shell, or in the orbital, this is where we find our negatively charged particles called electrons. So I'm going to pop an electron over there. Now, you may have noticed already the difference in size. So we've got here, you can tell that protons and neutrons are the same size, and electrons are actually smaller. In reality, they're far, far, far smaller than this in comparison to the nucleus. But for the sake of this, just keep them visual. We're going to keep that on there. Okay, so that's the basics of these things called subatomic particles, because if this is an atom, if this whole thing is an atom, then these make up the atom. That's why they're called subatomic particles. Now we're going to have a little look at the symbol we got over here, because this is going to be very useful to us in a minute. So here we've got helium, He, capital H, little e. And if you look at it in the periodic table, you will see these two numbers. You've got a number up here which is a 4, and a number down below which is a 2. Now the 2 is what we call the atomic number, also known as the proton number. Proton number. Now, unsurprisingly, the proton number tells us the number of protons in something. So this tells me that there are 2 protons in helium. So we're going to go ahead now, we're going to add to this diagram, and we're going to turn this into helium. So to do that, I'm going to need another proton. So here we go. There's another proton. So we've got 2 protons in there. Okay, so far that's all right. Now, something that's very, very important to remember in terms of how we draw atomic structure is that in a neutral atom, so in a neutral atom, so this is only a neutral atom, the number of protons equals the number of electrons. So if, for example, in this case, we have got 2 protons, then that also must mean that we have got 2 electrons. So I'm going to go ahead, I'm going to bring across another one of our electrons. Obviously, these live in the shells, so we're going to pop that in there in our shell. So number of protons equals the number of electrons. So if there's 2 protons, there are also 2 electrons in my neutral atom. Now, the other thing we're going to look at is this top number up here, the 4. So look at what that represents and what that means. Now, this is called the mass number. The mass number. So the mass of something is obviously its weight, okay? So its mass is how heavy it is. Now the mass number looks at this section here. It looks at the nucleus. It looks at the center of it, and it tells us what's in there. Now this number here tells me that in the center there are 4 things. Now at the moment we've only drawn 3 things. there are 4 things in there. Now we know that of those 4 things, 2 of them are protons, because we know that by looking at our proton number. So in order to find out how many neutrons there are, we just take those numbers away. So 4 take away 2 is going to be 2. So we're also going to need, in this case then, another neutron. So I'm going to go ahead and bring over another neutron. Okay. Okay, so we're going to go ahead and check this now. So I've got my 2 here. That tells me there are 2 protons. So here are my protons, my red particles there. In a neutral atom, the number of protons is equal to the number of electrons. So if there's 2 protons, there are 2 electrons. And I've got my mass number here, which tells me there are 4 things in the nucleus. So what's in the nucleus? And we know that protons and neutrons are found there. Protons and neutrons are found in the nucleus. So if then 2 of those are protons, then the remaining number must be neutrons. So 4 take away 2, that's how many neutrons there are, and that tells us. So here we've got our atomic structure of helium drawn out. Now, when we're drawing atomic structures, we don't necessarily draw it out like this all the time. In fact, this would be very difficult to do, especially with bigger elements. Helium is very small, but with bigger elements, this would be very difficult to draw out. So we're going to simplify this. This tutorial here is just literally to go through what these numbers mean and what they tell us. So in reality, when we actually draw these, we draw it a little bit differently. So we're going to have a little look at how we draw helium in a slightly different method. So we're going to remember here that the number of protons is equal to the number of electrons. So I'm going to go ahead and instead of drawing these out this time, I'm going to so I've got I've got a proton number, an atomic number there of 2. That must mean I've got 2 protons. So I'm going to write 2p there. So it's better, much easier to do than write it all out. So there's those 2 things. Now, if I've got 2 protons, I must have 2 electrons because the number of protons is the number of electrons. So what I'm going to use this time is I'm going to use crosses to show these. So there's 1, there's 2. So there are my electrons. And because we know that if there are 4 things in the nucleus and 2 of them are protons, then the remaining must be 2 neutrons. So that's how we draw helium in reality. So we're going to go ahead and we're going to look at, it makes it a lot easier to draw. We're going to go ahead and look at some other examples as well now. So let's go even simpler for a second, and we're going to look at hydrogen. So hydrogen is very small. As you can see here, this tells us here there is 1 proton. 1 proton. If there's 1 proton, then that must mean that there is 1 electron. I'm going to draw that up here. Okay, there's my electron. My cross equals an electron. So cross equals electron. And this is what we use to represent electrons when we're drawing them, is a cross. Now, if I've got 1 thing in the nucleus and 1 of those things is a proton, then that must mean there are no neutrons in there because 1 take away 1 is 0. So hydrogen is a bit unique in the fact that it has no neutrons. So the next one we're going to look at is oxygen, but there is something very important that we need to remember before we go any further. So this first shell here, this circular thing going around the nucleus, that first shell is very small, and so it holds a maximum of 2 electrons. I'm going to say 2e minus because electrons are negatively charged, so maximum of 2 electrons. So we can only fit 2 electrons in there. So that's going to become quite important here. Because if you look here, this tells me that oxygen has 8 protons in its nucleus. So I'm going to go ahead and I'm going to write 8p, 8 protons. Now, if I've got 8 protons, that must mean I've got 8 electrons. But if my first shell can only hold 2, that must mean it spills over into another shell. So oxygen has actually got 2 shells. 2 shells. So this is oxygen. Here's oxygen. So it's got 2 shells. I've already said it's got 8 protons in the middle. And I'll show you why in a second. If it's got 8 protons, that must mean as well it's got 8 electrons. So there's 1, there's 2. Now that shell is now full. We cannot fit any more in there. Kind of like a hotel. And on the bottom floor, it can only hold 2 people. On the next floor, it can hold 8 people, a maximum of 8. But if you look, we've already used 2 of them, so we only got 6 left. So there's 1, 2, 3, 4, 5, and 6. So I got 1, 2, 3, 4, 5, 6, 7, 8 electrons there. And as you can tell, and this is very important, I've drawn them on the north, south, east, and west points of my atom. Okay, because if you had them just spread all over the place, it'd be very difficult to see, very difficult to interpret. You need to make sure that you draw your electrons on the line, not above it, not below it, not next to it. Okay, so you couldn't do that, for example, not next to it. It's got to be on the line, and the examiners do check that. So that's that. I've drawn my protons, done my electrons. Now, this tells me here I've got 16 things in the nucleus. 8 of those things are protons. The remaining number must be neutrons, so I must have 8 neutrons as well in this. So I'll just make a note here now that the second shell, and any consecutive shells there, are bigger, and they holds a maximum of 8 electrons. Maximum of 8 electrons. So let's have a look at another one then. Let's have a look at sodium. So again, you can tell this is going to be a bigger one here again. So now in the case of sodium, again, we're going to need 2 shells here. So here are my 2 shells. I know that because I've got more than 2 electrons in this. So we're going to go through the same process again. Proton number there. So that tells me that I have got 11 protons. So 11 protons are in the nucleus. If there are 11 protons, there must be 11 electrons. So 1, 2. Remember that shell's full now, so I've got to go up to my next level. So there's 2. I've got 9. Excuse me. I've got 9 left. So I'm going to go ahead. 1, 2, 3, 4, 5, 6, 7, 8. Now that shell's full. Remember, maximum of 8 electrons in the next shell. So that means I've got to draw another shell. Ooh. So here we go. Here's my next shell. Shell number 3. And I've got 1 left over, and there it goes on the north axis up there. So let me just double check. So I should have 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's sodium. Now, I've got 23 things in the nucleus there. 11 of those are protons. So the remaining number must be neutrons. So in this case, we've got 12 neutrons. So don't always just assume that the number of neutrons equals the number of protons in the nucleus, because they don't. So this third shell holds, again, a maximum of 8 electrons, and I doubt you'd be asked to draw anything bigger than 3 shells. So to go a little bit more advanced, and we're going to do this just very briefly, we're going to look at electron configuration. So electron configuration just means where are those electrons found, basically. Okay, so where are they found? Electron configuration. So, for example, hydrogen, I'm going to just draw them directly below here. The electron configuration of hydrogen is simply 1, because there's 1 electron in that shell. Now, oxygen's a little bit more complicated. In the first shell, I've got 2 electrons, and in the next shell, I've got 6. So what I'm going to do is I'm going to do 2, 6. That is the electron configuration of oxygen. I'm going to do the electron configuration now of sodium. So I've got 2 in the first shell, so 2, I've got 8 in the next shell, 8, and I've got 1 in the final shell, 1. So that's my electron configuration of sodium. So this now then, with the electron configuration, we're not going to go into too much depth, but it is most definitely good to know, because we will be coming back to some other stuff later on, which is relates to electron configuration. So if you can understand that now, that's very important. Okay, so it's good to get your head around that now, about how we write this. So 2 comma tells me that I've gone up to a new shell. So if I was just looking at this electron configuration here, then this would tell me that there are 2 electrons in the first shell. There are 8 electrons in the second shell. And then finally there is 1 electron in the outer shell. And talking about the outer shell, that's something we're going to come back to a little bit later. So again, just be aware of that term. Okay, so that pretty much covers the basic principles of electron structure and how we draw these diagrams. We call these dot cross diagrams, which comes up frequently in the exams. It's good to know. So I hope that helps, and stay tuned, there's more to come.